Welcome. So I find it ironic that with this conference, we're talking about all these different events, and we wait until the end to talk about latency. So let's dive in on how you kind of solve that problem. So before we start, let me kind of introduce ourselves. So my name is Henri. I'm actually technical director at Schwab in the centralized architecture group in the CTO organization. And I've got two distinguished engineers with me. Craig Duero is one of the tech leads, and Tom Martin. They're going to do the most exciting part. I'm just here for the entertainment portion of it. But we wanted to share with you a couple of things, how we look at the world, specifically around Spring Cloud data flow, and truly embrace the latency engineering concept as well. So with that, before I start, I want to make sure that this is kind of clear. We're not here to give any trading advice by any means. We will leverage a demo that will highlight some of this, but by no means this is a reflection of what we do or what we recommend. So why don't we give a little bit of a background of Schwab? I mentioned it earlier in another presentation. At Schwab, we're highly focused around putting the client first. That means everything that we do, it gravitates us back to that core principle. And it's important because, specifically in this context that we're going to be talking about, the experiences that we deliver to our clients, like if you look at our front ends and all our channels, we want to make sure that things perform well and create a great experience for our clients so that they can do their activity with Schwab. Now, let's start talking about events. So this conference has all been about events. And I think we need to make sure we have an analogy. And I kind of want to thank Phil. He kind of set us up for the first keynote to start using some rubber duckies. So this is our problem space. So we live in Colorado, and you guys probably have done this before, have some duck race, right? So let's use it as an analogy. Let's treat all the events that we have just as ducks. So while we go through this, we'll kind of show them. Now, ducks are great because of the surface. They look very calm. But what we really need to know is how fast they're pedaling underneath the covers to kind of get a sense of what's going on. So let's dive in, a little bit of a level setting. So when we talk about event processing, and you've heard it throughout the conference, we've talked about all kinds of different events. And in the previous presentation as well, it was shown like how do you do event processing. And event processing in the context here are all composable microservices. But there's a lot of componentry underneath the covers that make that work. And you don't have too much of an insight to it. And the key thing is we need to understand what's really happening with the pipelines, because if there's n number of components running, how do you know what T is looking like in that? And where do you find your problems? All right, but as we know, the rubber duckies are great, but the moment I throw them in the water, this is more what reality is, right? They're all over the place, it's highly distributed. The duck number one, make it all the way to the end first, or which one happened first, right? So we need a way to figuring out how do we understand what's happening. So let's keep using the example. So if we line the duckies up, and we have a couple of binders, or dams, it's the basic pipe and filter approach that Spring Cloud Data Flow provides. So let's explore that more. So a question for you. What's this? This is the interactive part. Stuck duck. Something going on with the duck. It's taking a little longer. But how do you know? Okay. What's this? Something happened in the middle to the poor duck, and he didn't make it. Well, how do you know? So these are the things that we want to explore. The other part we want to explore as well is Spring is actually really good at actually hiding and being opinionated in many different ways. But if you peel the onion a little bit, see what's going on. If you look at the DSL, it's very simple. But there's a lot of things happening underneath the covers. I can inject Kafka. I can do RabbitMQ. I've got different binders. I can do partitioning. So there's a lot of moving parts underneath the covers, right? And what we want to be able to do is for the developers have a way of seeing what's actually happening and be able to ascertain what can I do with these things. So you've also heard in the conference the notion of Zipkin. Zipkin is a great way to accomplish distributing tracing. And for those that you guys don't know, there's a little bit brief history of Zipkin. Zipkin kind of originated out of Google, out of a paper called Draper. If you guys want to read, it's an amazing paper to get familiar. There's a couple of other related papers to this as well. But then the concept was taken and then applied with Zipkin at Twitter, which truly formed the Zipkin framework. Then it became open source through Adrian Cole. They've done a tremendous job in open sourcing this product. And now you can actually use it in many different contexts. So we're actually going to walk you through how we can leverage that with Spring Cloud Dataflow. But before we start, it's all about gathering telemetry, right? If you think about gathering telemetry, different points of injection and being able to trace that and then making sense of it. So if you think about a stream, what you really care about is the trace. From the moment the event enters into your system all the way to the end. That's one single trace. What happens along the ways is what we call spans. The spans allows us then to see what are the different discrete steps that happen in a flow or a stream. Underneath the covers, you can then use, in the Java world, Sleuth, and then feeding that into a Zipkin stream so you can then see what's happening to your streams inside of Zipkin. Now, keep in mind, Zipkin is instrumenting things, but it's only sampling data, right? It's a significant amount of data. So because of what we do, we always want to be very interested in this, that there's durability in this aspect of it as well. And to accomplish that, we leverage Sleuth as well to then say, persist this data into the logs and then get aggregated through the fire hose mechanism. But that instrumentation allows us to then also look at the logs, do additional analytics, do additional enhancements as well. And now I can combine both of best worlds. So I've got my telemetry and I've got my analytics that I can combine with the two different things. So this is a quick overview. This is the standard Zipkin image. But what you now can see is that I can see end to end how long my streams are taking, how long are the different components in the stream taken, and I can determine where do we have latency. And especially very important in streaming is streaming, its intent, there are long-running processes that you want to have run as fast as you can. So are there some pipelining activities going on or not, right? As I mentioned, it provides also partitioning. So are there cases where I can partition data as well so the streams can work more efficient? And obviously most important is where did an error occur in my stream? Because when I know this and I have enough information, I can make a determination, do I need to re-inject this back into the stream? Does a human operator need to take action on this or something else? But it quickly allows me to see where things are failing in the pipeline. Now, enough from me. Now more to the interesting part. So we're going to use an example. It's a trading example. It's no reflection of how we do things at Schwab. But it's a good example given that we're in the financial industry. So with that, I'm going to hand it over to Craig, who's going to walk you through to a great demo.
All right, so we are going to build a simple stream using Spring Cloud Dataflow, or Spring Cloud Stream are going to be our applications. We're going to use Spring Cloud Dataflow to deploy our stream. We are first going to deploy it without using Sleuth. We're going to show where Sleuth comes into play, why we would want to use it, and then show that same stream using Spring Cloud Sleuth. And before we get any further, I do just want to reiterate the disclaimer that any data that you see here is not live trading data. So this is just random data we're using for demo purposes. So if you make any trades based on this, you're on.
I just bought some stock.
You got that?
Yeah.
Okay.
Can't trade today, Tom.
Yeah.
So here's our requirement. Our client wants us to send them trade details every time we receive new trade events. As you can see from this diagram down below here, it's pretty simple what we're doing. We get a new event every time a trade occurs. So we get this event that comes into our system. All this event has is a trade ID. Our system then needs to aggregate some more information. We need to get the customer ID, the symbol, the action, the quantity, and confirmed, write this all into a string, and then send this downstream to our client. Pretty simple, not much to this. Let's talk about how we're going to design this. So using the microservice architecture, we are going to create 3 Spring Cloud streaming applications. If you're not familiar with Spring Cloud Stream or you didn't get a chance to go to some of the earlier sessions, there's a great session yesterday about Spring Cloud Stream. It is a framework that's used to build message-driven microservices or event-driven microservices. So that will be perfect for what we're trying to accomplish here. Our first application we are going to create is the source application. This is just going to be responsible for receiving the event. The transform application is going to be responsible for actually doing the heavy lifting of gathering those trade details, getting the customer ID, action, quantity, confirm, symbol. And then the sync application is actually going to be sending the event down to our client. If you look at GitHub, the Spring Cloud Stream sample applications, there's a sample application called TikTok. This is the same thing that we're doing here. We're just building on top of that a little bit for demonstration purposes. Once we create these 3 applications, we're going to then use Spring Cloud Dataflow to orchestrate and deploy our stream. These applications are pretty simple, but I'm going to dive into code real quickly just so everybody can be on the same page of what we're showing here. Let me jump over here. So we had the 3 applications. We had the source, the transform, and the sync. The source and the sync are pretty basic. I don't think we even need to show that, but I will just show real quickly what the transformer looks like. Because we're using Spring Cloud Stream, which is built on Spring integration, you can see we have an input channel and an output channel here. Our input is the message that comes from the source application. That's our payload that we have right here. We are then just getting the trade ID out of that payload, and then just getting a string together with all the details that we have. We're then logging our message and then returning it to the output channel. And then, of course, the output channel is the sync application. And because you're probably curious what these methods actually look like under the covers, I could just show you what we have. As you can see, all these methods here are just purely returning random data. And to simulate in the real world that we have some methods that take a lot longer than others due to processing or external calls, we're adding a whole bunch of sleep statements into some of these methods to show that some methods are going to take longer than others. Now that we build these 3 applications, we're going to now deploy it using Spring Cloud Dataflow. So I'm going to turn it over to Tom, who's going to show that portion of it.
Thanks, Greg. So Spring Cloud Dataflow is a Spring application which is going to help us orchestrate the creation and the deployment of Spring integration screens. So let me go over to, this is the GUI for Spring Cloud Dataflow. So there's a couple parts to it that we're going to show you today, how to register our applications here. We're going to show you how to create the stream, and then we're going to show you how to deploy the stream. So the first thing that we're going to do is register our 3 applications. 3. Our first application was our source app. The type is going to be a source. The source is kind of what starts off the event. You know, it picks it up from somewhere and creates the initial stream. We are going to be using Maven coordinates, but you can use HTTP or file for this. So we have SpringOne, and then we have the artifact with a version. The second application is our transform app. The type for this is going to be a processor. That's something that handles like business logic. It gets it from like a sink or creates it and then does something with it, and it sends it downstream again. So we're going to be using transform app. And then our last application is our sync app, which will then just be a sync, which is going to end our stream and send this to our client. Now, we are using the GUI for this, but all of this is scriptable. There's a client and everything else, so you don't have to do this through the interface. So we're going to register our 3 applications now. And this doesn't do anything besides kind of telling Spring Cloud Dataflow the name of our 3 applications, and where to go find the jars or the artifacts. So we are now going to go create our stream. On the stream thing, they give you a listing of all the definitions. Right now we don't have any. So we're going to click on Create Stream. Under this, we can, if you want, there's a couple different ways to do this from the GUI. If you want, you can type in source app, and then pipe that to transform app, and then pipe that to sync app. And then you can see the 3 applications we have. You can see the events flowing through there. There is another way you can do this through the GUI if you want. You can just drag out source app, take out our transform app, and then take out our sync app. And you'll see they're red because they're not connected yet. You just drag these in here. Pretty simple to do. So you have our stream now. So now what we're going to do is create our stream. So we just click Create Stream. We give it a name. Good timing. I need to do an installation real quick, I guess. We have SpringOne. So we're going to click OK. Now you can deploy the stream from here, but for this, I'm wanting to show you the definition. So now we've created this. We have SpringOne, and you can see that our definition has source app, transform app, and a sync app. And over here for status, it's undeployed. So all we have to do is hit the deploy button. Spring Cloud Data Flow will deploy our 3 applications. It'll also create the, since we're using Rabbit in our case, it will create the exchanges and the queues, all needed for the communication between these. But for demo purposes, and it takes a little while to deploy this, and sometimes there's issues, we're going to skip the deployment for this, but it is as simple as hitting the deploy button. So now that our 3 applications are happily working, let's go look at our logs. We'll first look at our source app, and this is still just a Spring Boot app. We go through our logs and just see it starting up. At the end of this, all we're doing during our source app is just logging the trade ID is 173, that something happened. The next application for our logs is our transform app, and we can still just scroll through here after it's started up. For our transform app, all we're doing is adding more business logic that the client wanted. We had a customer ID, the symbol, and what's actually happening with it. And then for our third app, our sync app, as we scroll down, we can see that its message has been sent to the client, everything's working, our stream's great, we can ship it off to production, we can go celebrate. Whoop, whoop. See my whoop, whoop.
So at this point, everything's working fine in production. We're happy, we're good to go home. But we get a call from our client saying that there's a problem with our stream. According to our client, our stream is running too slow. It's working, but it's just taking too long. Being good developers, what's the first thing we always do when somebody says that our code is slow? Blame somebody else, exactly. So we would like to do that. We would like to tell our client that the problem's not on our side, it's really on your side. But unfortunately, we can't do that. And that's because we don't do any latency tracing on our side. We have no idea how long our stream is really taking. So we don't know if our client is correct. If our client is correct, we don't know which components are slow. We don't know how to go about fixing it. We don't even know where to begin. So how do we solve this? Well, the first approach that most teams will take before they get onto Sleuth is they'll decide, well, this isn't too hard. I can write something myself that will measure the latency here. They'll probably start off with a source application, maybe log a timestamp when the event starts, send that timestamp down through the headers, and then the sync application log another timestamp, measure the difference between the two, and say, here's our total time for the stream. I'm not going to show what that looks like for the code, but you could probably imagine. It's not overly complex, but there might be a couple intricacies we need to work out. If we actually did that, though, our logs might look something like this. So here's our sync logs. We might say, our message was sent to the client, and our total processing time for the stream is 695 milliseconds. Now, this is OK for giving an overall picture, but there's a couple major drawbacks of going down this approach. First drawback that you're probably all noticing right away is we might look at this and say 695 milliseconds is too long, but where do we go from here? How do we know what to fix? The second drawback that I see is if we've put some code in the source application, some other code in the sync application, we might have some tight coupling between the source and the sync, which in a microservice world is definitely something we want to avoid. Now, both of these we can fix if we spent a lot of time coding and coming up with a framework and all sorts of logic to measure different methods, different applications. We could. But that gets into what I think is the biggest drawback of going down that approach. And that is, this really isn't our core business logic. What separates us from our competitors is not our latency engineering code. It's not all of this platformy code. It's our core business logic. So the less time we could spend focusing on this stuff, the more time we can spend focusing on our core business logic. So what is the alternative? Well, as you probably guessed from the title of this talk, the alternative is Sleuth. So here's SpringCloud Sleuth page. Definitely read this if you want to get more information, all the references, sample applications, definitely read through this. Henri had touched upon this earlier, but I do want to just reiterate that the difference between Sleuth and Zipkin, we're going to be talking about both of these, but it's important that you understand the difference. Sleuth is the library that is used for actually doing the latency tracing. This is going to be logging how long our applications are taking. Zipkin is a standalone application that's going to be aggregating all of those Sleuth logs together and providing a UI for us to be able to analyze and troubleshoot what's going on with our application. So let's take a look at what it takes to add Sleuth into our three applications, our source, our transform, and our sync. If we open the POM file here, we're using Maven for this demo, but of course this will work with Gradle or anything else. We add these three dependencies here. I do want to just call out this last dependency that you see here, this rapid binder. You might be wondering what we're doing with that. So for Sleuth, once we add Sleuth to our applications, we're going to be logging these Sleuth spans and traces. But we need some way of getting that data over to Zipkin. There's three ways that we could go about doing that. The first way is doing that via HTTP, or we could use Rabbit, or we could use Kafka. In this demo, we're using Rabbit, but if we wanted to use a different mechanism, we would just change this last dependency here. Once we add these dependencies and to our three applications, we would then redeploy our stream. I'm not going to show that again, but it's the same process that Tom had gone over. And then we're done. Everything is working. We have Sleuth working in our application. Now, what do we do with those Sleuth logs? Well, that's where we have to deploy Zipkin. Zipkin is a standalone app, so we don't need to use SpringCloud Dataflow. We could just do a CF push for Zipkin. And there's two ways we can go about deploying Zipkin. We could just do just grab the jar from GitHub and just do a CF push on that. Or we can stand up our own Zipkin application if we actually wanted to. And that would look like this. As you can see, it's just a simple Spring Boot app, except we just have this annotation at enable Zipkin stream server. And that's it. We would then push Zipkin out to our environment, and then we're good to go. So let's take a look at what our trace looks like. So a couple things to notice here. First thing right off the bat, the upper left-hand corner, you see the total duration, 691 milliseconds. So this is nearly identical to the previous one that we saw. We see the number of services, the depth, the total number of spans. And we also see down below here a graphical representation of what is going on in our application. Henri had mentioned this earlier as well, but I do want to reiterate this point one more time. Difference between spans and traces. A span is the smallest unit of work in Sleuth. So each of these bars that you're seeing here is an individual span. If we click on one of these spans, we can actually drill in and see the information that comes along with the span. We have timestamps, we have some key value pairs, we have some IDs. All that is part of a span. A trace is a number of spans put together that measures an entire stream or an entire event from beginning to end. So everything that you see on this page is all part of one trace, which you can see even in the URL. That's the trace ID that we're looking at up there. A few other things that you can see in Zipkin is if you click on this dependencies, you can see a dependency graph of your applications. For our demo here, this is pretty simple. This might not give us that much information. But you could probably imagine if you had a large stream, a lot of taps, you might be calling some other REST services that you have, this could be very beneficial to see what's actually going on in your applications. The other thing here, if you click on this JSON, you can see the underlying Sleuth logs that are being sent to Zipkin. Probably don't need to see this, but if you ever are curious and want to see what Sleuth is doing under the covers, or you want to troubleshoot, this information is always available. So where are we at now? So we now see our source, our transform, and our sink here. We see all three of these applications are running as part of this trace. But I think we could pretty clearly see which application is the problematic application. Source is fine, sink is fine, but transform is taking 593 milliseconds, which is almost the entire time. So this is great that we've now gotten this far that we can see transformer as a problem. And right now we have had to add no code. We just had to add a couple dependencies. But where do we go from here? We had all those methods. We had the get customer ID, get symbol, get action, get quantity. How do we know which one we should focus our time on? Well, seeing that Tom was the one that wrote most of this bad code, I'm going to turn it over to him and see if he can figure out what's going on.
Well, thanks, Craig. I appreciate
Tom.
it. I guess I should have taken that training on unit testing. So as we can see, I mean, it's great that he found, the transform map is the one that's slow. But transform map, it has thousands of lines of code. I mean, how am I going to find where the issue is? It calls out to other services. It does quite a few other things. There's a lot of processing. I don't know. So Sleuth gives us the benefit of a couple things that an annotation. Let's jump over to code. And since I can't, do stuff on the fly during a demo, I have it already written for us. So Sleuth has this @new span that you can put on any method. And as you can see, we've put new span on extract trade ID, get customer ID, get symbol, and so on. So we can see, hopefully in Zipkin afterwards, where the problem is. So we'll go back over to Zipkin. And this is after I've recompiled it. We use Spring Cloud data flow to push it out, but we do instant deployments here. Okay, so we have our transform map, and we can see still here that our transform map, the span for this is still 600 milliseconds, but it's given us a lot more details now of, extract trade ID, get customer ID, I mean, that's 10 milliseconds. So we can see get symbol. This is 350 milliseconds now. So it's actually given me a lot more information just by putting an @new span on these methods to pinpoint which method it is in, the problem. So I didn't actually write this get symbol. Craig really did, so it's his fault. So I need a little bit more information about what's happening here. We've tried to trace it down, and I think it has to do with one of the symbols that we're actually processing. For each one, we do things a little different. So it'd be nice, Craig showed you this. We have these, the host and the method. It'd be nice if we could get some extra data on one of these spans so that I actually can see which symbol it is. So let's see how we can use Sleuth to do that. We'll jump back in code. So Sleuth has this tracer class, and this is where it creates the traces for you. It has a method here called add tag. So anytime this tracer add tag, it'll add a specific tag to the current span. So for like this example, it's going to be adding the symbol and the stock exchange. So when we come back into Zipkin, after we've redeployed it, we can click on the get symbol, and on here I can see, oh, the stock exchange is NASDAQ and the symbol is Google, and I go, okay, we do extra processing for this tag. So now I can go back in there, fix the code. Since it's a really simple change, who needs to write a unit test, of course. So we'll push this out to production, and I can go back and celebrate. Whoop.
So in typical Tom style, he made the change in his box, said it was working, pushed it out to production, and ran home before he could actually validate that it was working. And so now we get a call from the client saying that there's an even bigger problem. Our stream is not working at all. They're not getting any data. So is there any way that we can see what's going on by using Zipkin? Well, let's take a look at the latest trace. So here's the most recent trace. A couple things that jump out right away is our total duration is 3.2 seconds. Probably something else that you notice is we never even got to the sync application. We see source, we see transformer a couple times, but we never got to the sync. We also see a lot of red bars here. As you probably would imagine, these red bars indicate that we are having an exception in our code. If I click on one of these spans here, we can see what that exception is. So in that get symbol method, we are throwing a null pointer exception. We can also see that same exception is bubbling all the way up to the top of the transformer. And so the transformer is dying. We're not getting anywhere with the transformer application. Now, to get these exceptions, there's no code that we needed to add. Just by the nature of having Sleuth in our application, it handles all this. The other thing that you're probably noticing is all these gaps between, we're seeing the errors a couple times and we're seeing gaps. You may have guessed this already, but this is the Spring retry logic in action. So by default, Spring Cloud streaming applications will try the application once. If it fails, which is what's happening here, it will wait 1 second, try it again, which is what we're seeing here. We'll wait, if that fails again, it will wait 2 seconds, try it one more time, and then if it fails, it just gives up. Spring says, we can't handle this. So it's pretty neat that we can actually see that retry logic. We can actually see what's happening with our application. Another very common permutation of this that we might see is that maybe the last retry did actually work. Maybe we did make it out to our sync application. That might be an indication that our get symbol method is calling some external resource that is periodically down. That happens quite a bit. And those are really hard to trace down because the message did work, the stream did go, the message did go from the beginning to the end, but it just took so long. And so it's very useful to be able to jump in here and see, oh, well, our get symbol method is failing a couple times, but then finally goes through. So let's say that we go ahead and fix this error. We follow proper TDD this time. We push our application out to production and redeploy our stream, and now our trace looks like this. Looks a lot better. We've gotten rid of our errors. Our total duration is 365 milliseconds. We brought this down quite a bit. Our get symbol method is down to 20 milliseconds. Great reduction in that method. And so where to go from this point? Well, maybe we say we're good with this. Maybe we say 365 milliseconds is okay. Maybe we say we still need to optimize this more. If we need to optimize this further, well, we'd probably just look at the next longest method, which is this isConfirm method, and see what we can do about this. Of course, we can look at any of these methods if we wanted to, but why even bother spending time on this extract trade ID method when this is taking 61 microseconds? Not even worth our time to open up that code. So what Sleuth will give us is it will give us information so we know where we should really focus our efforts on. For the sake of argument, let's say that we're okay with this time. We say this is good enough, this meets our SLA. Everything's working happily in production until one day we get another call from our client that says, they say, everything is okay except every day during a 15-minute window of heavy trading volume, we're seeing the stream is slow again. So can we see what's going on during that window? Well, something else that we can see in Zipkin is we can actually look at all the traces in one page here. We can look up by time, we can sort by various metrics here. And so we can look up and see what is our longest trace. So we're going to take a look at this and say, sure enough, our client is right. There's one trace that is taking 1.2 seconds. If we were to take a look at that trace, here is what we would see. Looks a little bit different from what we've seen before. Our total time, like I said, is over a second. Our source or transform and our sync look okay. The method that we had optimized is fine, 20 milliseconds. So what's going on here? We have this huge gap in between our applications. Now this had us stumped for a while. We were wondering if there was something wrong with Sleuth, or maybe this wasn't rendering properly in Zipkin. But the more that we looked at this, we eventually realized that exactly what we're seeing here is what's happening with our application. That there's a long delay between the source application and the transform application. Now, if you remember back in the beginning when we were talking about Spring Cloud Dataflow, Tom had mentioned that we're using Rabbit as a binder between these applications. So what's happening now is we're having heavy trading volume, so there's lots of events being processed. The source is picking up a whole bunch of messages. It's then dropping those messages onto the queue. The transform application is so busy that it can't pick up those messages off the queue fast enough. And so this message that we're seeing here, this event, was processed from source very quickly, spent almost an entire second sitting on the queue, was finally picked up by transformer, and then flowed all the way through to sync without any problems. Of course, if we were going to solve this, if we were going to fix this, a couple different ways we could do this. We could probably further optimize transformer. We could increase the number of instances of transformer, or maybe we just figure out some other parallel processing. A couple different ways to do this. But hopefully this does demonstrate, though, that even though there's really not much we need to do with our applications to get Sleuth on them, there's a lot of very useful information that we can extrapolate off of this. I'm going to turn it back over to Tom for a couple.
Thank you. Okay. So we've talked about some of the simple features like new span and things like that that Sleuth gives you. And if you want more information, it's best to go to the SpringCloud Sleuth page, and they have a lot of stuff. A couple of things that we wanted to mention during this is some of the customizations that you can do. The default sample rate for Sleuth is 10%. So that means 10% of the events that it creates are going to get sent to Zipkin. And it tricked us for a little while thinking, hey, all the events are going to be here, why they're missing. But it's only 10%. It's like a sampling rate. But you can configure this 100%, if you're wanting to figure something out in production or something. We gave you the new span annotation. And what that does is it looks at the method name and then creates the span name based on that. But if you want it to be more configurable, you want your own names, you can just say @newSpan and then give it name equals blah, like SpringOne, and it'll create those names how you want it. So with the new span, that basically will have Sleuth creating a new span each time a method gets hit. But sometimes, you're in the middle of a method and you have a little tricky bit of code and you want to create a span in the middle of a function and the new span won't work. Tracer has a thing of create span and close span, which will, in the middle of your code, if you add that, will create a span and close it for you. It also has a continue span feature so that, let's say you stop a span and then you go into a new thread or something, since Sleuth doesn't support going into a new span, you can actually pass that on, continue the span, and go over into a new thread. It has span injectors, so if you don't have, what we have here, if you need more customization, they have the trace ID and the span ID are all created in these injectors. And if you have your own correlation ID that your company uses, you sometimes want to use those. You'd create a span injector and actually use that instead of the trace and the span IDs that are generated from this. And out of the box, Sleuth is integrated with REST template, Feign client, and Hystrix, and the async. So in our examples, you didn't have to write any code. You put the libraries, the dependencies, and it just works. So if same thing in a REST app or something like that, or your Stream app calls a REST app, it'll automatically just pass that in through if you're using REST template or Feign client. No need to do that in the headers. A couple things to be aware of that Sleuth with Zipkin is not a complete login solution. As we've shown you, you'll have a single trace, and you'll find out, okay, great, my method takes 300 milliseconds, but you don't know the average time. You could just have the one event you're looking at could take 1 second, but the average time is actually a minute. You don't know. So there's other things that you're going to have to do to get that type of logging. It doesn't do reporting or alerting. So even if you had those exceptions in your Sleuth, there's no way within it to actually trigger an alert so you know your production environment is failing, for example. So to implement Sleuth, you might actually need to refactor some of your code. Let's say you have at least to get better sampling rate with your spans. Let's say you have a method, a couple thousand lines of code, let's example, and it does multiple different things. And you use the @new_span annotation at the top, and you call your stored proc here or something, you write out to Mongo, you call another web service, something, and you can't see what all those things are doing. So it might be good to break that part out, put them in a new method, or use the create and close span like I was saying earlier. Make sure all your annotations are in a bean class. You can use that new span, but if it's actually not a bean, Sleuth won't pick it up. And you'll be wondering why, that you put that new span on there and it's not actually showing up. You either create a bean, put a component at the top of the class, and you'll have it. A couple of things about implementing Zipkin. You want to consider how much data you want to sample. Like I said, the default's 10%. That might not be enough for you. You might actually want it 100%. Completely configurable, pretty simple. The default data storage I'm having was in memory. It does support, MySQL and Cassandra. I think that's it for now. In conclusion, Sleuth and Zipkin can be extremely valuable for latency and event tracing. Integrates, as we showed you, pretty easily with Spring Cloud data flow. There's no coding required to get started. All we did was add a couple dependencies and we're done. And even if you do need to add a couple spans here and there, there's minimal coding to actually you just put it at a new span and you can actually get more event tracing that way and so on. Now, I'd also like to point out that Henri did not kill any ducks in the beginning of this show, so we like our ducks.
So with that, we wanted to annotate this presentation as well, because it's a SpringOne. We're definitely hiring. We're significantly hiring. So we're very interested in folks that all the things that you've learned during this conference are things that in one way or another we're leveraging. But those are all things that you can help contribute to as well. So we're definitely thank you for attending. The team has done an amazing job over a short amount of time to implement these things. And we're looking forward to the next couple of iterations with that. So with that, we wanted to turn it over. If you guys have any questions, we'll be glad to answer. Oh, a lot of questions. Let's start on the left side. Yeah, so the question is there support for convergence and divergence capabilities? You guys can probably add these, but in general, as long as you use the same Sleuth intrinsics, or I should say Zipkin, you can also span different technology stacks. And actually, even in PCF Go routers by default inject these pieces of information. So the short answer is yes, as long as they use a Zipkin instrumentation, it will carry it through to the infrastructure.
And that's kind of the point of using REST template or Feign client. All these things, if you have Sleuth in your application, it will automatically send the trace ID downstream. And so it will take care of all that under the covers.
It's the trace ID that goes from the beginning to the end, and it's just a little spans. But yeah, the trace ID will be the same. So even if you're diverging like this, it will. I'm not sure about the coming back together part of it, but the trace ID will be the same, but I don't know about it, yeah.
The spans will be different as long as you can maintain the trace. Yeah. Good question. There was another question over here. Yes, question.
Can you search in that log, you were doing the trace log, right? And if I want to know what you find out some information on particular syllabus?
So the question is, can I search for particular tags or bagging? You guys want to take that?
That's a good question.
So we added like the HTTP host in there. You can type, and I'm not sure the complete syntax, but you can say HTTP host equals, like SpringOne, and then it will find them like that. Or how I added that tracerat tag. If you wanted to find just specific Google symbols or whatever, you can search for them like that. Or if you have like a external correlation ID system, and you want to still use the trace ID and ID, you can search for those things in here too.
We just see it.
Unfortunately, we don't have an example.
I think if we just look up Google and might actually find it here.
Yeah, I think you have to
No.
do symbol.
Yeah, okay.
Yeah.
Yeah, don't remember the syntax, but yeah, you should be able to
Yes.
do that.
Has some capability. Next question.
You said that by default you had a 10% sampling rate. Is there a way to guarantee if there was an exception or if the total time was over a certain threshold, that would definitely be sent to Zipkin?
I don't think so. We're actually,
Yeah, so I think the short answer, I don't think there's a specific piece that you can say. The sampling is more done at a different level. So it separates it that way. And that's why we're kind of clear up front as well, is that it has a sampling, but it doesn't, your logging piece, you still have to have that in place as well. So you combine the two.
What you might want to do if you wanted to see that, you wanted to capture everything that was taking a long time, you might be able to just write something on the data source side, so MySQL or Cassandra, just to purge periodically all of those traces that are small, that you don't care about. Yeah. You might be able to do something like that and do a sample rate much higher than 10%. You could do something like that, yeah.
Yeah. Great question. Question over here.
What if we don't have SpringCloud, and we still use Zipkin as well in our application? Because I know that you guys had source, transformer, and sync. So what if we don't have this structure now? We just wanted to use it to a couple of microservices that are connected together. All this connection has been done manually.
So the question is, if you, to make sure I understand, so if you create your own microservices and they deploy not to,
Yeah, so the only thing you need to do is you can use the Spring Boot app, the Spring MVC, like a REST controller, and you can just add those dependencies, and it will start doing it. It supports Spring Cloud Data Flow, or Spring Integration, really, and web. It's independent. Spring Cloud Data Flow is just what kind of deploys our applications for Spring Integration.
Yeah, so you don't really have to use Spring Cloud Data Flow per se, if I understand your question correct. The concept of Zipkin, just in general, it transcends Spring Cloud Data Flow. It's for our specific use case that we've chosen to use it to allow us to have the tracing and latency engineering in there. But as you might notice, during the keynotes, there was also kind of mentioned ICTO, which is the sidecar approach. Underneath the covers, its tracing is actually also based on Zipkin. So what you'll notice is that beyond transcending Spring Cloud Data Flow, if you're doing other mechanisms, if you start using Zipkin concepts or Sleuth concepts, you get that traceability across different technology stacks, different ways you're approaching as well.
And if you looked at these logs under the covers, you could see there's nothing that is specific to Spring Cloud Data Flow. These are just Sleuth logs that are just, you can put this in any application or use REST template or anything to send it to other applications. So if you're not using Spring Cloud Data Flow, you should still be able to utilize this.
You know, if you're using something like a SOAP service, an old legacy SOAP service, it's not going to have the integration we showed you, but it's easy enough to create your own. It can be supported even if Sleuth doesn't support it by just using the create, span and close span, and you can have the same functionality in whatever application you're doing.
Yeah.
That just enables Zipkin to read stuff from Rabbit, where all of our applications for this example are sending messages to Rabbit, and then Zipkin's reading off Rabbit. That's all it does. It says, use Rabbit, for really, or the binder that's defined.
Good.
Have you considered using Zipkin for slightly different use cases, like, for example, auditing of data, or trying to trace, it's a little bit stochastic control, because you get some sampling, but still can give you some idea about the region distribution data. So is this
Make sure we get, so the question is that you can,
have you considered, for example, using this approach for slightly different use cases, like the auditing? The main question there is who did what, when, and stuff. So trying to trace, it would be again additional based on the sampling parameter, but still maybe can reduce some insights.
okay, so thank you for clarifying that. So the question is, can you use it for some other auditing and kind of have the ledger of things that have occurred. I guess theoretically you could. You have to overcome the sampling. That's one, so it doesn't become stochastic. The other part you have to consider as well is how Sleuth actually write things out that might not be as durable as you require, right? So like what we mentioned, like if we inject rabbit, rabbit MQ is not directly persistent on the first go, right? Versus writing out a log message that tends to be faster going to I/O. It depends, I guess, what your audit requirements are, how stringent you need it. In our industry, that tends to be very stringent. So we might choose a different option for that. Yeah. Sure, question.
You mentioned durability. How long do these logs and traces stay?
So right now,
Repeat
this
the question.
example here.
Repeat the question.
Oh, sorry. So they're asking how durable these messages are in Zipkin. So for our example, we're using memory. So it fills up to about 1 gig on this, and once that's gone, it gets rid of old ones and puts new ones in there. So this right here in our example using memory would last, a couple hours depending on use. It does support Cassandra and MySQL, so it depends on how big your database is.
Yeah. It's really your choice. So Zipkin provides a couple of storage providers. Like what Tom was saying, you can use MySQL, Cassandra, there's also Elasticsearch, and then it's just your choice on how long you want to keep it there. There's a couple of other interesting projects out there as well that actually leverage that data, then provides analytical aggregates, where they actually take the data, run Spark over the data that's in Zipkin, create some other analytics as well. I would definitely encourage you to look at OpenZipkin. And there's a large community out there that shows all kinds of other additions to the solution set. Even Uber is getting in the game right here. All right?
Question, so how is the trace ID passed to the next service?
Yeah, so it's a great question. So how, you guys want to answer it?
Yeah, so how the trace ID is passed to the next service. So the two things, we're showing you Rabbit. So in the example of this, the trace ID is sent through the Rabbit message headers, and it'll just have the trace ID and the span ID, and it's just sent through the headers. It's done the same way when you're using like Spring MVC and doing like a REST call. The trace ID and the span ID are sent, and other data too, are sent through the headers.
Yeah.
Yeah, so again, on the OpenZipkin, there's many different implementers. So depending on the transport technology that's being used between 2 points, they will choose which way they will head us. So like what Tom was saying, Rabbit uses the message headers, HTTP headers. For the other protocols, they use some other means for doing that as well. But from a developer perspective, it's, you don't
And
know.
also, if like I was saying earlier, the span injectors, if you don't like how Sleuth is doing it, you can change it. So there's an interface for that.
Can roll your own if you don't want it. Great. Any other questions? Great questions. So with that, well, thanks for your guys' time, and thanks for the team. They put it all together. So